everybody. This lecture is about ocean resources, and before I start, I just want to remind everyone that we have the end of the semester coming up, and so let's talk about some of the important dates in this. So this week we are having our regular lectures, our regular 3 lectures. Next week, however, that's the last week of classes. So we'll have one regular lecture, we'll have one review lecture, and then we're going to have on the last Friday of classes, we will schedule a Zoom meeting for anybody who wants to attend, so it is optional. And that gives you a chance to ask any questions that you would like before your final, because your final will be on May 13th at 10:15. It is very important that you attend to that exam at 10:15 on May 13th, unless you tell me beforehand that you cannot do that at that hour. All right. You need to communicate with me if you can't take the exam, then we'll find some way for you to take the final exam. All right. I will do my best, my absolute best, to get everybody a fair shot at doing well in this class. We're in a weird time. It's unprecedented. I want you to do well, but if you don't communicate with me, I will not have any way to help you. So keep that in mind, please. All right, now that that business is done, let's talk a little bit about ocean resources. And the first question that we want to ask is, who owns the ocean? If you think about this, like, people, you can buy parts of land. You can go out and buy a house, you can buy a ranch, or you can, buy huge tracts of land, whatever, but you can't buy the ocean, right? The ocean is not owned by individuals. Instead, parts of the ocean are owned by sovereign states. For example, the United States, or actually even parts of the ocean are managed by individual states. But parts of the ocean are owned by no one. So let's talk a little bit about that. So the Law of the Sea Treaty is the treaty that basically governs how the whole international community decides who's in charge of what part of the ocean. All right. So we have different zones of management for the ocean. So within 3 miles of the United States, and this is unique for the United States, within 3 miles, the state manages what happens there. So here in Georgia, from the coastline to 3 miles out, the state's in charge of that. And sort of one of the unique ways that you might understand this is if you live in Brunswick or near here, we have a casino ship, right? That there's no gambling in Georgia. You're not allowed to gamble in Georgia. So that casino boat has to go 3 miles offshore before gambling can occur. All right. So that's sort of an interesting management way that we manage things. But we also see that in fisheries. So for example, we have within 3 miles of land, the state manages the shrimp fishery, but outside of that 3 miles, the federal government does. Now, as we get outside of that 3 miles, we have 2 different levels of jurisdiction. And really, we're going to talk about what's called the Exclusive Economic Zone, or the EEZ. All right. So individual countries have the authority to manage 200 nautical miles out from their shoreline in these economic zones, these exclusive economic zones. And then what they manage there are drilling, offshore drilling, fishing, pollution control, and scientific research. All right. Now, even though you manage those waters, you manage what happens in them in terms of who's going to drill for oil or who's going to fish in there, it doesn't mean that other countries can't pass through those waters. So we have what's called free and innocent passage. That means that if I am in a sailboat, I can sail through another country's waters without being managed by the EEZ. Now they may have some sort of immigration process that needs to occur, but they can't stop me basically from just sailing through. And that's important in a lot of ways when we think about ocean management. So for example, the United States Navy often will sail through these waters here as a show of force, to show China and these countries in here that we have the power to sail through there. And because China can't limit our navigation through those waters. All right, so the Navy often makes a point to sail through those waters. Now, beyond the exclusive economic zones, so all of these red parts here, those are under the control of some country, all right? Some nation controls them. But all that blue part, no individual country manages those. And beyond that, those are managed by what's called the International Seabed Authority, and that is a group of nations basically that gets together and manages that. But really, most of the resources that are valuable are within this red zone here, within the economic zones. Let's take a look at our economic zone. So the red here is our economic zone. We have, look at this, all of this stuff around Alaska. We have right off of the coastline of California, the Gulf of Mexico, all the way up to Canada here. We have islands that are in the Caribbean, Puerto Rico, and the United States Virgin Islands. And then we have a lot of territory that is out here in the Pacific. All right, so Hawaii, we have the Hawaiian island chain is thousands of miles long, and then we have a few atolls here that we also control. Guam, for example, Wake Island. So we have the largest EEZ of any nation. That makes us a very powerful and rich nation. It's 6.2 million square miles, and it's actually larger than the terrestrial part of the United States. One of the important parts of our EEZ is that it is very, very large because we have all of these islands out here. Okay, these really make it very, very large. So these islands can be really, really tiny, but we control 200 miles out from them. So the EEZ around each one of those islands is very, very large. So those islands make our EEZ huge. Let's talk about part of our EEZ that is disputed. So when you have countries that are bordering one another, treaties basically, an international body decides where the limit between one country's EEZ is and another one. And where the United States meets Canada, we have some disputed territory. This is called the gray zone. And so here's the United States. We've talked a little bit about this area before. Here's the United States. Here's Canada, and this is the disputed boundary area. Now, within this boundary area, there are a couple of islands. This is called Machias Seal Island. You can see this is only 500 feet, so this is like 2,000 feet across, maybe. There's a little rocky outcrop here. Now, there's a lighthouse, and I have visited this island several times because it's near where I used to run a field station in the summer. It is an important seabird colony, and there are a ton of puffins there. It's really quite amazing. You go ashore for about an hour. They put you in a bird blind, and you're just surrounded by these guys, right? So there's not much out there besides these seabirds, a lighthouse, but interestingly, Canada always has a member of the Royal Canadian Mounted Police there, always. And they do that because they want to make a point that they own that island, right? So who cares about this island? It's just a bunch of seabirds, right? Well, what these countries actually care about is not the seabirds. What they care about is the waters around it, because those waters are full of these guys. Well, now this is a really large lobster, but these waters are full of lobsters. So American boats want to go and fish there, and Canadian boats want to go and fish there. And these are what these boats look like. Okay. So these two countries really both want to have this water so that they can get the economic benefit of catching these lobsters here. So what they have decided to do is share it. So the United States basically governs the fishing fleets here. The Canadians basically govern the fishing fleets here. And in here is called the gray zone, and they work together. They both can fish in here. They both manage it together, so they've come to an agreement about this. Okay, so this is an area where we still don't know who owns this island, because the Canadians will tell you that they own it, but the Americans will also tell you that they own it. All right. So, and there are disputes like this all around the world. This is just an example here in our country. Now, one of the things that some countries do is they try to lay claim to islands so that they can increase their EEZ. And one great example of this is what's going on in the South China Sea right now. So China is up here. Of course, China is a gigantic, gigantic country, lots and lots of people that they have to feed, and they want to claim as much of the ocean around them as they possibly can. And so one of the things that they are doing is down here, these are called the Spratly Islands, and they tend to be these coral atolls. And we've talked about coral atolls before. And what China is doing is they are taking coral atolls that don't have they don't protrude at all from the ocean. So they have no island, they're just an atoll, and they will build an island on top of them. So they can see this is a man-made island on top of this atoll. And they have put a military base here, but they put a lot, they don't always put military bases there. They put all sorts of economic things on them. Not only does this increase their military power because they have bases far from their home base, but China is hoping that they can use these islands that they now say they own to get 200 miles of territory around them to control and to basically get the economic benefit of. And this has been, if you're the Philippines here, you're not happy about it. If you are Vietnam, you're not happy about it. Indonesia is down here. They're not happy about it. Brunei is not happy about it. So there are a whole bunch of islands that, of nations here that are very unhappy about China doing this. And the international community, this is something the international community is dealing with at this point. How do we deal with China's actions on these man-made islands? Let's look at some of the individual marine resources that that countries are interested in. So one of the big things that countries want to control is petroleum. So we use petroleum every day. We use it to heat homes. We use it for manufacturing. We use it to drive our cars. We use it actually in plastics. Think about all the plastic things around you, all those plastic bottles, all the plastic things that you buy food in, all of the household goods that are made of plastic, those are all made of petroleum. All right, so we use a lot of these. Petroleum is an important resource for us. So what is petroleum? All right, so the first thing to know is that it is a hydrocarbon, and it has hydrogen and carbon in it. All right, and the bonds between carbon and hydrogen have a lot of energy. So when you burn hydrocarbons, it releases a lot of energy, and you can use it to do things like power a car. Okay, so hydrocarbons are found in sedimentary rocks. It is the remains of plankton. All right, so plankton basically over the course of millions upon millions of years die. They settle. And if they settle in a quiet, shallow, biologically productive area, you tend to, in millions of years, form hydrocarbon resources. All right. The place that they settle has to have an anoxic bottom, and that makes sense because if you have decomposers at the bottom, they will those nutrients will get broken down and they'll go back into the food chain. But if you have anoxia, then these plankton don't decompose. Instead, they get buried. And as they get buried deeper and deeper, temperature rises. Okay. And this transforms them into either oil or natural gas. So oil is produced at lower temperatures, natural gas is produced at higher temperatures. And so what we find is that, here's a diagram of what we see. We have sandstone here, which is a type of sedimentary rock. We have shale here, all right, which is a little bit harder, right? And so it's not penetrated by the oil. So we get these reserves of hydrocarbons that are between these sort of layers of impenetrable rock, right? And so we will drill for this. Basically, we put these big oil rig platforms up. We drill down through the sea bottom, through these sort of softer sediments, into the shale, and then down into this sandstone here, and then we'll pull the oil or the natural gas up. All right. So what do these rigs look like? These big deep sea rigs look like. So depending on where they are, they need to be either simple or more complex. And over the course of the past 50 years or so, we've become very, very good at true deep sea drilling. So traditionally, drilling had to be limited to fixed platforms where they actually would rest on the bottom like this, and you'd drill up. And then as as our technology has uh, advanced, we've been able to have these floating platforms where drilling actually will occur, and these will float above it. Okay, so we're now able to pull hydrocarbons out of the bottom as deep as about 2 miles. All right, so at first we could only get these from sort of really shallow areas. Now we can get them from very, very deep areas. So this is what one looks like, a really big oil rig. See these right here? This is how big they actually are. Look, this is like a hotel, right? These are huge. All right, so these are huge oil rigs. And in some areas of the world, these are very, very prevalent. So this is the Gulf of Mexico. This is Louisiana. New Orleans is like someplace right around here, right? So Alabama, the Florida Panhandle, Texas. And if you go to the Gulf of Mexico there, each one of these dots is an oil rig. That means there's a lot of oil reserves here. Okay, so these can be very, very numerous depending on where you are in the world. Let's talk about some of the issues that come with using petroleum from the seabed. So the first thing that we're going to talk about is what's called sonic exploration. So when they drill for this, they don't just like randomly go out and plunk an oil rig down. These oil rigs cost millions upon millions of dollars, so they want to make sure that wherever they put it, they're going to get hydrocarbons, all right? So they need to find the hydrocarbon first, and then they build the rig. And at this point, what the technology that is used to find hydrocarbons in the ocean is actually very, very controversial. So they have a survey ship here. It has an air gun here that makes a series of shock waves. And these shock waves are incredibly, incredibly loud, like much louder than a jet engine. And they basically pulse this over and over and over and over, all right, every 10 seconds for days and days. They drag behind them this array of hydrophones, which are just microphones that work underwater. And depending on the pulses that they get back, so this sonic wave basically travels down. It travels through different types of sediment differently, and depending on which hydrophone it hits, scientists can tell what's down there. So they can tell if there's hard rock, or if there's soft sediment, or if there is oil. So this is how they find this. Now, this is really, really loud, and it is very, very controversial, and it's something that that oil companies want to do off the coast of Georgia right now. Okay, a lot of organizations oppose this. This guy here, he is a commissioner on the coast of Georgia, and he opposes it. And he opposed it so strongly that he came to his county commission meeting, and they were questioning one of the geologists who wanted to do this, and saying, "Is it disruptive?" And the geologist, basically said, "Oh no, it's just a little bit of noise, and it's just occasional." So this guy got out this air horn and basically blasted it every 10 seconds to ask, "Now, is that disruptive or not?" So what we find in areas where they do this, we find a reduction in fish there. They either are killed by the sound because it's so disruptive to them, or they swim away. We find that there are issues for marine mammals as well. This is actually a really interesting conservation issue in our area. And so right whales live off the coast of Georgia. This is a highly endangered species. There's less than 400 of them left. And so one of the big concerns is that if we're blasting these poor right whales with this noise, are they going to survive this, right? So this is one of the issues with petroleum, is how do we find it? We also have the issue of spills. So this is the Deepwater Horizon spill that occurred. Well, you guys were relatively young when this occurred, but it's not that old. The Deepwater Horizon was one of the big oil rigs that I showed you earlier, and it basically had an explosion in 2010. And what happened was it just started to spew massive amounts of oil out into the Gulf of Mexico. So this is where it was located, here off of New Orleans. And this is a satellite picture of the gigantic, huge, massive oil spill that occurred because of this explosion. And this had pretty significant effects on the Gulf of Mexico, and it still has effects to this day. So this is 10 years ago, but we still see effects from it today. So some of the immediate effects, we saw all sorts of wildlife that is covered with oil. So oil is toxic. It's toxic for a lot of reasons. It's directly toxic, but also it makes it hard to swim. It basically coats you if you're a wildlife. So this is a salt marsh turtle called a diamondback terrapin, and you can see that it's just covered in oil. These are pelicans that are covered in oil and are at a wildlife rehabilitation center. If you're a bird and you get covered with oil, well, your feathers really are not designed to have oil on them, so they no longer are able to be waterproof. It's hard for them to be buoyant. It's hard for them to be stay warm. So this is a big issue for these pelicans. And then we saw toxic effects in bottlenose dolphins as well. So this is an example of a huge spill, but oil spills occur every day from these big oil platforms, and they all have some sort of effect on the environment. Now, the final impact, of course, would be the release of carbon dioxide into the atmosphere, which contributes to is really the primary driver of climate change. And we're going to talk a lot about that in a future um, lecture, so I'm not going to talk too much about it here. Let's just talk a little bit about other mineral deposits besides hydrocarbons. We're not going to get too deeply into these, but basically some of the resources that are found on the sea bottom would be things like sand and gravel. And here are, in the United States, some of our sand and gravel resources. A lot of gravel up in New England, and that would have been carried there by glaciers. And then a lot of sand resources here. We actually don't use these a lot because it's very, very hard to get. It's costed to get, but it is something that countries are always interested in because it might be useful in the future. We have manganese nodules. Here's a manganese nodule. It's actually not just manganese. There's a bunch of metals, basically, that are found in these nodules on the sea bottom. This is one of the other mineral resources that might be useful to humans. There are certain areas of the ocean that have a cobalt-rich crust. Cobalt is a very important element in that it does things that no other element can be used for. And one of those examples is building jet engines. You need a lot of cobalt for it. And finally, we have phosphorus deposits. So phosphorus is one of the important elements that we find in fertilizer. So that's one of the other mineral deposits we find on the ocean floor. Now we've talked about mineral deposits, let's talk about living resources that are part of the EEZ of different countries. So um, when we're talking about living resources, we're really talking about seafood, all right? So let's talk a little bit about some of the types of living resources that countries use. So here we have a swordfish, all right? So this is a pelagic marine fish. We have tuna. This is an albacore tuna. If you eat tuna from a can, this is one of the species that is used for that. We have codfish, all right. So this is one of the another one of the marine fish that is uh, a, a resource for countries. And this is one of the most important marine resources historically, and it actually drove a lot of the colonization of the United States. Beyond fish, though, there are other living resources. For example, we have mollusks. So we have mollusks here in our graph here. So mollusks would be things like blue mussels or oysters or scallops. All right. So if you've ever had a scallop in a restaurant, this is what a scallop looks like. And the thing you're actually eating is just the mussel, the mussel that closes that scallop. But it's actually, there's a whole bunch of that animal we don't eat. See each of these little dots here? See those? Those are eye spots. They have blue eyes, so they actually have eye. They can sense what's around them just by seeing it. We have crustaceans, and that would be things like blue crabs, or this is an American lobster. And then finally, we have aquatic plants, so seaweeds. This is an example of a seaweed that is harvested. This is called Chondrus crispus, and it's used as an emulsifier. So basically, there's actually a traditional recipe with chondrus where you can make pudding with it. I used to make it for my students when I taught up in New England because chondrus is a common seaweed up there. But this emulsifier is used in things like, oh gosh, all sorts of things like toothpaste or ice cream even. If you eat ice cream, it probably has an emulsifier that has been taken from Chondrus crispus. So let's look at how living resources have been harvested in the ocean. So this is actually millions of tons here. They left the units off of this, but this is millions of tons. And you can see since 1950 how much our harvest of living resources has increased. So we have different colors here. So pelagic marine fish has probably quadrupled in the past 60 years. Demersal marine fish has increased. Basically, all of these categories have increased, and this suggests that countries are increasingly using the living resources of the oceans around them, and that might be because there's increasing demand. It also might be because we have improvements in technology that allow us to harvest more. But this pattern is seen around the world where we are taking more and more things from the ocean. So how do we get these living things, all right? How do we get these living resources? Let's talk a little bit about some of the ways that we fish or we collect things. So let's see here. One of the things we might use is a trawl net, a bottom trawl, all right? So this is what it looks like in the water. They have these are called doors. These are sort of hard, they're usually made of wood, and they're connected to, oops, they're connected to ropes that connect up to the boat, and the boat pulls these ropes through the water, and this pulls this net on the bottom. And you can see that it has floats up here, and basically this acts as a great big mouth that scoops up things from the bottom. So let's see what this looks like when it's traveling over the bottom. This is an animation. So there's the net. You can see the trawl.
A bottom
doors
trawl
here.
is a type of fishing net that's pulled along the seafloor. Fishermen commonly use bottom trawls to catch shrimp and bottom-dwelling fish like halibut and sole. In addition to these target fish, however, the nets also catch a variety of ocean life that's usually thrown back dead or dying. Dragging heavy gear across the seabed can also damage sensitive seafloor habitat. Reducing the harmful effects of bottom trawling requires either modifying the fishing gear or limiting the areas where trawling is allowed to protect sensitive bottom-dwelling organisms and their habitat.
So if you eat local fish from Georgia, this is how shrimp are caught here using these big trawl nets, okay? Another way that you might catch fish are by using purse seines, where you have a boat that basically surrounds a school of fish, kind of similar to the way that we saw those dolphins surrounding a school of fish, or those whales surrounding a school of fish. Well, we wouldn't use a bubble net or a mud plume. We use a net. All right, so they're surrounded, and basically this is then pulled into the boat, and you can see this is in Chile. This is fishing for sardines, and you can see how vast this catch of fish is here. Another way that you might catch fish is using a long line, and it's literally a long line. It's a long rope. So here's the fishing boat. Here's the rope. It's suspended from floats, and we have fish hooks that basically are hanging off of it that are catching fish. So that's a long line fishery. And some of the targeted fish for that would be sharks or tuna, or we have swordfish here, all right? Um, we also might catch fish, or we might also might catch marine resources using traps. So this is a lobster who's walking into a trap, but we use this for blue crabs here in Georgia. And then another way that we might catch them is with a gill net. So this is a net that basically floats on the top. It has weights on the bottom, and it's basically a curtain of a net that fish then swim into and get caught in. So these are some of the ways that we catch seafood. Now there are issues with many of these methods because we have a lot of conservation issues that occur. So one of the things that happens with trawling is the bottom can be disturbed. So this is a live reef bottom that you can see it has all sorts of things living on the bottom, little anemones and seaweeds and worms and things like that. And when you drag a trawl over it that has the chain holding it open, that can really that can destroy all of this. And so this is before trawling and this is after, all right? We can have, this is a ghost net where a net has been abandoned or lost or abandoned, and that continues to fish. It just keeps fishing and the fish are never removed from it, and we end up with a lot of organisms dying because of that. You can have bycatch as well. So this is bycatch from a long line where we have this is that hook that's hanging down. This is an albatross that was attracted to the bait on that hook because it was hungry, just like the tuna or swordfish or whatever, and it basically that hook got caught and this albatross drowned because albatross breathe air, right? So it couldn't get back up to the surface, so it drowned. And this is bycatch from a gill net where a turtle has gotten caught in it and has also drowned. Okay, so this is something that's not unusual in fisheries. And then finally, we just have the problem of overfishing. So you can see how efficient some of this technology is. This is a huge amount of fish. It's become a little bit too easy for us to catch fish, and that means it's easy for us to overfish some of our resources. So let's talk about some of the ways that we can avoid these problems. All right, so let's see here. The first thing we're going to talk about is a turtle excluder device, and this is put onto trawl nets. We saw the animation of the trawl net being pulled behind the boat, and one of the problems that happens with those is that if a turtle gets caught in that, it can't outswim the net and it will drown. Okay, and one of the ways that we avoid that is you put a little device on the end that anything big in the net basically gets diverted out of it, and this is what that looks like. Here's the catch, right? So this is what it looks like coming out of the net. And here's a turtle that is, he basically ended up in the net and he swam out. He's getting out of a net. Many of the fisheries that involve trawls, where there are turtles, have requirements to have some sort of turtle excluder device on them. All right. Another way you might reduce bycatch is having some sort of signal to animals that you don't want to catch that there is a net there. And so an example of this would be pingers. So this is a gill net here, right? And this is a pinger, and this pinger is literally pinging. It's making a noise. So fish and dolphins have different abilities to hear. They can hear at different ranges. Dolphins can hear very, very high pitched noises, and fish can't. So these dolphins can hear the pingers, but the fish can't, and this warns them that there's something there. All right. Another way that we avoid bycatch, especially with long lines, but you also can use these if you're an individual fisher person, is we use these circle hooks. And you might say, oh, this poor turtle, right? So this turtle has bitten down on some bait and has gotten this this hook caught in its mouth. But look, if you catch a turtle like this, you can just cut this off here and you can pull this out, and you know, it might have been traumatic for the turtle, but he's going to live through it. This is the alternative to the circle hook. This is the circle hook. So this turtle has basically taken two types of bait, right? The circle hook is here, and it didn't go down its throat. And this is a regular hook, and it fit down in its throat. And this is what did the turtle in. This is what killed the turtle, whereas this did not. So circle hooks are one way of reducing bycatch of all sorts of organisms. Another way that you can avoid bycatch is by changing the type of rope that you use. In New England, there are a lot of lobster traps, all right? And one of the problems with lobster traps is that these guys get caught in them. This is a right whale, and a large number of right whales are killed just by getting caught in the ropes that are used for lobster traps, because those ropes traditionally it was floating rope. So there was a lot of rope for them to get caught in. So this is floating rope here. And not too long ago, these fishermen had to get rid of their floating rope, and they had to buy sinking rope instead. And so that kept the rope down on the bottom. And this was not easy for fishermen to deal with because they had to buy a bunch of new rope. But one of the interesting things that some companies have done with all this leftover rope is they make these rugs out of them. All right. So if you ever see these recycled Maine lobster rope rugs, this is a good thing to buy. All right, so reducing bycatch is one of the ways that we better manage our living resources in the oceans. Now let's talk about overfishing. All right, so we've gotten very, very good at catching fish, and we have more and more people who are catching fish. And so we see over and over in the world fisheries that become overfished. And let's just talk a little bit about this one particular fishery. So this is cod, all right? This is Atlantic cod, and people have been catching cod in the United States, well, in America, for a very, very long time. So fishermen came here well before the Pilgrims came here, and they would come from Europe, fish for the summer, and then they would go back to Europe and sell their cod. All right, and cod were actually really, really important for some of the first settlers here, and they not only were they important for them, but they drove a lot of the trade between the colonies and Europe. So this was a really important fish for hundreds of years. Right? We harvested these for hundreds of years. So let's look at some of the traditional ways that these were harvested. So you can see this is back in the 1800s. This is cod being caught way back in the 1800s. All right, and in this place right here, this is called Newfoundland. So this is Maine. This is Nova Scotia. This is Newfoundland. So it's further north than Maine. And this is part of Canada. And a very, very robust cod fishery was found there for 100 years, over 100 years. All right. And it supported all these little tiny towns. So Newfoundland is really the island does not have a lot of roads in it. People got around by water, and they lived in these little villages called outports that were basically up these almost fjord-like bays. All right, and they survived by cod fishing. So let's take a look at what happens to the codfish stock in Newfoundland starting in 1850. Right, there you can see about 100,000 tons were landed then. And this catch went steadily up, right, into the 1940s. Look, there's a dip here. That's because of World War II. But then they go up a little bit. But wow, look at this. Look at how high they go up here. So one of the things that happened at around this time is that our technology to catch fish became really efficient. We got efficient engines, we got efficient nets, we found ways to catch cod that we'd never had before. So we got really good at catching them. And so, look, we caught a lot of them. But then look what happened. It just dropped straight down and then dropped down to basically nothing. In 1992, there were so few cod caught that the Canadian government had to basically close the fishery. They issued a moratorium on cod fishing. And that meant that all these people, all these thousands of people who live in these little outports, right? They no longer had any way to make a living. So a lot of these outports, this is what they look like today. They're abandoned basically. And all these communities and this way of life is gone because of overfishing. So we see this pattern of overfishing in many of the fisheries of the world. So we have sardine fishery, and you can see that we have a catch that is increasing and suddenly, whoop, gone, right? We have red snapper, that these numbers plummet, and we're not going to worry too much about the axes here, but basically each one of them is some indication of either catch or biomass. So red snapper in the Gulf of Mexico plummets. We have the New England groundfish catch. So groundfish are things like cod or pollock, and it is plummeting here. All right. We have white marlin here. That in 1950 this was the catch, and then it plummets here down to this level in 2000. All right, and even some types of shrimps. This is the main shrimp harvest, and it has plummeted as well. So this is a pattern that we see very commonly in the world's fisheries. And one of the concerns is that we sort of are fishing through all of these different types of fisheries. And when we have a fishery that basically drops like this, we call it collapsing. So this graph looks at the percent of species collapsed, all right? And so here, this is 1950, and this is on the x-axis, we have time. And then this axis, this y-axis is a little bit funny because this is 0. This means there are no species fisheries that have collapsed, and this is all of the fisheries have collapsed, right? So if we look at this over time, the pattern suggests that we have a greater and greater percentage of our fisheries that are collapsing. And if you basically model this out, if you predict what's going to happen in the future, look at what happens to this prediction. This basically predicts that not too far in the future, we'll have many seafood species that the species has collapsed. All right, so around 2050 we'll reach a real crisis where most of our fisheries have collapsed. Now things aren't all doom and gloom, because we are able to manage fisheries, and as a country, as an international community, if we want to, we can manage fisheries. So so on our x-axis we have time. On our y-axis, we have the number of stocks that are either experiencing some overfishing or that are overfished, okay, depending on the color here. And then this blue, this tells us the percentage of stocks that are overfished. And one of the trends that you'll see here is that in the late 1900s, we have a much larger proportion of our fisheries that are overfished, but recently you can see that this number is actually stable and is lower than it had been, suggesting that maybe we're getting better at managing our fish stocks. All right, and this is something that we can see in several of our fisheries. So here, this is northern cod spawning. All right, so the red line is what we need to have a sustainable commercial fishery, and the blue line is where we are, right? So in the 80s it was high, we had this plummeting, right? And then we had almost no stock here, but look what's happening with this number, right? So it's coming back up, suggesting that the situation is getting better for northern cod. We also can see this for striped bass. So Atlantic striped bass is generally considered a success story conservation wise. So we have this is time on the x-axis. On the y-axis we have landings, so the number of fish that were caught. All right, starting in 1982. So this line is commercial landings, and then we have recreational landings here. Okay, so if we look at this, landings were very low in the 80s and 90s, but look at how high these landings have gone up because we are better at managing them. This suggests that the stock has increased, so the number of fish out there are either increasing or stable. Let's move on to aquaculture. So we've talked about catching fish in the wild using all sorts of techniques. But one of the ways that we get our seafood is through aquaculture. And this means that we basically farm them. We farm all sorts of things in the world. So we farm scallops and oysters. This would be things like blue mussels. We have crabs. These are shrimp. Okay, prawn and shrimp are basically the same thing, shrimp. And then Atlantic salmon. So we basically farm all sorts of seafood. All right, let's look at some of this. So these are, this is an oyster farm here. All right, this is oyster aquaculture that's occurring. And each one of these bins here looks like this. All right, so it's a bin full of oysters. And these oysters are pulled out occasionally. They're raised from larvae. All right, there's basically a facility that has oysters that reproduce, and they take the spat, the little baby oysters, and they put them into different sizes of boxes out there. And these are quite large at this point. Let's see how these are processed. This is a tumbler, and they tumble them to sort them. They also tumble them because it causes them to have a little cup shape to them. And when people buy these in restaurants, they love to have oysters that are cupped, basically, because they're easy to eat. So let's look what these look like here. So that's how they
One of the more
sort,
essential pieces of equipment on an oyster farm is a
and shape
tumbler. The tumblers are used to wash and sort the oysters as well as promote better shell shape. Some of the features of our tumblers include an upfeed and discharge conveyor that allows you to dump oysters into a hopper, which feeds the oysters into the tumbler and then out a discharge conveyor, so you can then hand sort the oysters. The hoppers on the upfeed conveyor can be custom ordered to fit what your needs are on the.
So let's look at this is just in one state, Massachusetts. This is oyster aquaculture production, basically how much it's worth, what its economic value is. And starting in 2011 and going to 2015, just over the course of about 5 years here, this value has grown from 5 million to over 20 million. So this is something that has become really big business in the United States in the past few years here. And where do these go? Well, these basically go to restaurants. So if you've ever gone to a restaurant and had raw oysters, this is where they tend to go. A lot of places, especially up north, they have what are called buck-a-shuck nights, where it's $1 per oyster. And people eat these raw. Some of the other types of aquaculture we have, so these are blue mussels, and you can see that this is a rope, and there are ropes hanging down from it, and these ropes are covered in blue mussels. And see this? These basically are baby blue mussels that have settled on this rope. They'll do this in the laboratory, basically, in a laboratory setting, and then they'll put this rope out into the ocean, and they grow up, and you get all these mussels, all right? And they will harvest them, and then people will eat them. This is aquaculture for kelp, and you can see how it's in all these nice rows, right? It's also attached to a rope. And then this is a shrimp aquaculture farm, which look how gigantic it is. Let's focus on just one type of aquaculture here. This is Atlantic salmon. So these are Atlantic salmon that are in a salmon pen. So these are farmed Atlantic salmon. And when you go to the store and you buy salmon, most of what you buy are what are called fresh farmed or farm raised salmon. All right, and this is what it looks like here. There's also wild salmon that you can buy, but most of what you buy is farmed. And let's look at what's happening to wild salmon populations. So this is pre-fishery abundance in North America. So what is pre-fishery abundance? This basically is the measure of salmon before they are harvested. And if we look at the number here, so this is 1971 and this is present day. This number goes way down. Look at this. So this is the number here. We have a plummeting fishery here, and this green basically is the level that we need to reach to have sort of a stable population. All right. So why are these numbers going down? Well, one of the big reasons that we have problems with salmon, wild salmon populations, is that we have have destroyed their way of getting to their spawning grounds. So salmon are what we call an anadromous fish. They are born in fresh water. They swim down rivers and streams, the freshwater rivers and streams, to the ocean. They grow to maturity in the ocean, and then when they're mature, they swim back upstream and they reproduce. Okay, so let's look and see what this looks like. They need to be able to swim upstream. Their spawning grounds, they had to swim up all these little riffles, all these rapids, right? But we have dammed a lot of those waters, so we have basically blocked their passage upstream by dams. Now, one of the ways that we try to make this easier is we build this is called a fish ladder, right? And it's like basically an artificial rapid that they can swim up. It's not particularly effective, unfortunately. They can do it, but not a lot of them do. All right, so this is one of the reasons that wild salmon populations have fallen. So the number of aquaculture pens for salmon has risen dramatically. If you buy salmon, you probably buy aquaculture salmon. So what do these farms look like? This is an individual salmon farm, and you can see they're round pens, all right, that float on the surface, all right, and this is sort of a cartoon of this. We have a boat that comes from land and tends them because they need to be fed, they need to be given antibiotics, they need to be given medicine, they need to be harvested. So this is one of the boats that is tending to them. There's this walkway around it that people are able to walk on, right? It's covered with a net to keep birds from getting in there, right? And then this net hangs down, and it is a round pen that they swim around. Okay, and they're able to raise these salmon very efficiently, and they are able to make a lot of money doing it. Now, unfortunately, aquaculture is not an easy answer in terms of conservation. You might say, "Oh, that's great because all those wild salmon, they're not pressured by fishing." But there are problems with aquaculture as well. So one problem is we have the overfishing of feed fish. So all of those fish in that pen, they need to be fed something, right? And they're fed other fish that are basically processed into like a chow, right? Dog chow. Well, there's salmon chow as well. That they can be overfished. One of the problems that we find is that when you have that many fish in one small space, you get disease that spreads from one fish to the other. Just like we have social distancing for COVID-19, well, there's no way to social distance in that little pen. All those fish are close together. So you can end up with disease spreading very easily, or parasites spreading very, very, very easily. And they need to be treated for that. And that treatment is not always environmentally friendly. When you have that many fish in a small space like that, they poop, and so we have a lot of waste effluent from that area. And then also we have escaped fish. So when you have wild salmon have a lot of genetic diversity. Each little creek that they swim up is different genetically because wild salmon will swim back up the creek in which they were born. So you have a lot of diversity genetically, but you don't have that in aquaculture fish. They're all very, very similar genetically. So if they escape, they can mate with the wild fish, and that can interfere with the genetic diversity of wild fish. So there are a lot of problems with aquaculture. There's also a lot of promise in aquaculture, and this is a lot of what happens in the ocean. You have trade-offs. You have good things and you have bad things, and so as a society, we need to manage some of these, all of these things, so that the good things outweigh the bad things. Now, how can you know what good use of living resources from the ocean is? Well, one of the ways that you can do that is get one of these little cards. So a lot of organizations will distribute these cards, and basically green light, yellow light, red light, right? So these organizations will help you understand seafood that is sustainably harvested or that has minimal environmental impact. And so everything here on this green, these are all the best choices you can make if you want to eat seafood. These yellow ones, well, they're not as good. And then these red ones, these are all things that should be avoided. And they could be things like they are fished unsustainably, or there's a lot of bycatch, or things like that. All right, so this is one of the things that you can get if you're interested in making sure the seafood that you eat does not negatively affect the oceans. All right, on that note, I'm going to say goodbye to you all. I hope everything is going well for you all. And please communicate with me. Let me know what's going on. All right. And I will talk to you again later. Bye.